talking about Turing machine. That was our main topic. So there, if you remember the Chomsky hierarchy, I told you about something started with a finite automata, and then after that we are talking about an acceptor here. So particularly this acceptor of this PDA is divided into two parts. First part was your DPDA, deterministic PDA, and the second part was your non-deterministic PDA. Okay, so after that there is another acceptor that we have not done, that is your linear bounded automata. So that part is not in your syllabus, don't worry about it. I will tell you, if you understand Turing machine, I will tell you only here the length of the tape is fixed. Okay, so don't worry about it. I will, when the Turing machine is over, I will tell you about it, that what exactly is a linear bounded automata. Don't worry about that part. Now we are at the end part here, that is your the acceptor of all the acceptors, that is your Turing machine. Okay, so Turing machine is, as you know, is devised by Alan Turing, and it is one of the most powerful machine, and it accepts something called, there are two grammars. I will again completely talk about it when I discuss about it in detail. If you see, if you remember that, firstly, when I'm introducing you to the Chomsky hierarchy, there was only I did not tell you about these two different things. Okay, so I am combining it here. So it is again divided into, Turing machine is again divided into two parts. So something that is that I will tell you about it. Okay, so first of all, we just know how to accept, how to draw a Turing machine. Okay, so there is one very good what I say, one very important exception in this one. So there is an exception. So in most books it is not written, but if you study it very deeply, you will find that Turing machine, this is an exception. Okay, so Turing machine cannot accept epsilon. Okay, so Turing machine cannot accept epsilon. Okay, keep in mind. So always Turing machine cannot accept epsilon. So for that, what we'll do, what we try to code this as a special case, that whenever the epsilon is coming, we just accept it. Okay, so in all the machines I will build, you will never find that I'm accepting a epsilon, because that your initial state will never be a final state. You take any book, you will never find this case. Okay, so that is a very deep thing that you will got to know, that when you studied three or four different things, that you will always, there will be a, always they give you a question like this, when n is greater than 1. Okay, so in every book they will go with this approach, they will never go with this approach, e raised to power n, b raised to power n, where n is greater than equal to 0. So that is not possible. So I've studied about this. So keep in mind that there is an exception in Turing machine, that it cannot accept your epsilon or your lambda. Okay, so all the time we consider this epsilon as a special case, so we assume automatically that epsilon can be accepted, but keep in mind that it's a very important exception. And this kind of questions, if you are saying that your TOC is your favorite subject, is can be asked in your interview. Okay, so that is a very important part. It's not most of the people know about this particular exception. Okay, so now if I take an analogy, that what exactly is a Turing machine. So think of the Turing machine as a children who does not know how to count. Okay, so suppose suppose there, this is your Turing machine. So it is a 2 3 year old children that does not know how to count. Okay, so now I give the task uh, to this child to count the number of candies. Okay, so I have given, there are two bags here. So suppose there are two bags, bag one, and there is a bag two. Okay, so I gave this child like suppose I give here like 1 2 3 4 candies, and I have to give in here 1 2 3 4 candies. Okay, so this is bag one and this is bag two. So I tell this child to count the number of candies, that they are equal or they are not equal, something like this. Okay, so what this child do, because he does not, or he or she does not know about the counting, that how to count. So what can she do? She can, or she can take this candy out and place it here, take this candy out and place it here. So first task will be this, and second, take it out, place it here. In the similar way, third, and fourth 4. By seeing this approach, the child can say that the number of candies in bag 1 is equal to the number of candies in bag 2. So I don't know how much are they, but they are equal. Okay, so that much I can tell you that they are equal, but I don't know exactly how many candies are there in the bag. So second approach that can be used, because it is a quite labor intensive task that you have to take out the candies and just place it here and again take out the candies from there. So that is a labor intensive task. So what at the second time what this child do, he or she just what exactly take this bag. Okay, this is bag here, this is bag here. So what exactly does the child do? Take the candy out of here and place a mark here as X, and take the candy here and place a mark here as Y. Okay, so take the here also mark it on something like a sand that I have take C 1x, and then there are 2x, and then there are 3x, and then there are 4x. Okay, so in the same way there are 2y 4y, and it can write it on a sand that there are that number of x's and they are equal to the number of y's. Okay, so that will be other approach because the child does not want to do a labor intensive task. So what it do, it take the candy and mark it X and write the X on a what do you say, on a piece of paper or on a piece of sand. Okay, so there is a sand there and it is writing like that. Okay, so now this is another way that this is now I can say this as a Turing machine. Now what exactly Turing machine will work on the same thing. Now I'll say to the Turing machine that count the number of A's and the number of B's. Okay, so first of all, if I take any particular string, suppose I take a particular string. Now what I'll do, I will place this string on a tape. Suppose this is the tape here, there is a blank symbol. So this, if you remember, the Turing machine contains infinite length. It has an infinite length of tape. So it is your input and it contains at the left and right of it blank symbols. Okay, so this is B is denoted by a blank. And now what exactly is happening? Suppose your pointer is standing here. So first of all, now what, how you count the number of A's and number of B's are equal. So it will move towards the left of it. Okay, so it will move towards the right of it and see that there is a 1A. So what I'll do, I will mark it that I have seen a X and mark it by in place of X. I just mark it because if you remember the this finite control head can read as well as write on the tape. Okay, that is why I'm writing on the tape that I have seen this symbol one time. Again, I will move to the right and I will say that I have seen the first B and I'm marking it Y. Okay, in the similar way, I again move to the left and I've seen I will again mark it as X. And again, I will see the number of Y's by moving to the right. I will see also a Y, and I will again see a B and I will mark it again uh, a Y here. So by marking a Y here, I will again move towards the left of it to find any A. Okay, so if I don't find any A, I can directly again, because first of all, just let me see here. Okay, so when I mark the end Y, I will move towards the left of it to find A. Okay, so there will be no A. I will stop at blank. Now from blank, I can again move to the right of it to find any B. Okay, so if I do not find any B, I can directly say I land at a blank symbol. I can directly say that it means that the number of A's are equal to the number of B's because I have marked the number of X and number of Y's. So I can directly say that the number of E's are equal to the number of B's. Okay, so it will be more beneficial if I just solve the question of Turing machine. So the question will be again a classic question that is your A raised to power n and B raised to power n. Okay, so if you remember, you can make a push down automata. If you remember again, there is one another thing that what if a particular language is regular, you can directly say that language can be a context free language, and that language can also be a context sensitive language, and that language can also be a unrestricted what you say, this language recursive language. Okay, so now if you're seeing this one, this particular language is not regular, but it is a context free language. Okay, so A raised to power n, B raised to power n is a classic example of a context free grammar, context free language. So you can directly say that it is also For context sensitive language, it is comes under context language, context sensitive language, as well as comes under a context recursive language. Okay, so similarly the acceptors, in case of acceptors, I can say again this particular part, that the acceptor of this is finite automata, that acceptor of this is PDA, acceptor of this is LBA, and the acceptor of this is Turing machine. Okay, so now if you remember that this particular language is accepted by pushdown automata, so I can also say that this particular language can also be accepted by linear bounded automata and a Turing machine. Okay, so that is why I'm again making a Turing machine of the language that is already accepted by your pushdown automata. Okay, so the Turing machine can do all the work that is done by its lower ranking officer, as well as it can do its own work that is not done by any other acceptor. So that is the knowledge that I've told you before it. Now just take a little bit of example, like this is your blank and this is your blank. Suppose I take 3 A's and then I've taken 3 B's, and then there, because the tape is infinite, you can consider that. Okay, so the first part, now if you remember the transition symbol I can also write it, so you don't get confused here. So the transition symbol was, I think it was Q. Okay, so I just again verified, I do not want to write it wrong. Okay, just week 13 was week 14. Okay, so the transition symbol was this one. Okay, so this is a X, so your X was your tape alphabet. Okay, so tape alphabet, everything that you are putting on the tape, it can be your input also, but it can be other symbols that you are going to write. Okay, so now it can be written as Q into X and then Q into X, as well as left and right. Okay, so you can write, it can move on to any state, and it can put any read or write any particular symbol, and it will shift left or right. Okay, so that was your transition symbol. Now start with the Q naught state. Now if it will be more clear to you when I draw it, so start with this one. So now this is your Q naught. Okay, so now Q naught, I'm at the starting point, I will be at suppose I am at here. Okay, so my pointer is at here. So it's a courtesy, it's just a common courtesy that your pointer will be here, but if your pointer is given directly here, you can assume here also. Okay, so now if you want to assume it here, so I'm just talking about that whenever I got a. Okay, so now whenever now my pointer is here, I'm considering my pointer here. So if they are talking about a particular pointer, they will give you the position, but you can take your pointer at anywhere. So whatever is convenient to you, if the pointer location is not given to you in the starting one, but I'm just assuming that they always in the questions the pointer location is not given. So I am considering that my pointer location, my finite control is at A. Okay, so now I'm saying that by seeing the input A, I am marking it X. I am marking it, just wait a second. I am marking it X, and I am moving it to the right of the T. Okay, so I'm moving it to the right of the T. Okay, so I'm just saying it. Now, when you are moving right, you will get number of A's here. Okay, so there will be number of A's, and you will get a number of the B here. Okay, so you will write when you get when you are parsing through the right, you can get. Now I have to write a loop, because by only this step, by A, X and right, that it will only get to this place. Okay, so the loop, why I'm writing the loop, that till if there are number of A's like 100 A's, so it will keep moving on to the right until it finds a B. Okay, so now it is standing at here. Now I will say again, if another A is coming, and you what you do, if another A is coming, so do not do anything. So I'm not marking it till here, because I have to first mark, then find a B, then mark Y. Okay, so if there in the when you're moving right, there is any A you get, you do not do anything, remain the A as it is, and you keep moving right. Okay, so I'm just doing this, just keep moving right. So when I keep moving right, I will encounter my first B. Okay, so what can happen, I can encounter my first B. So I will again change the state. So when I encounter my first B, then what I'll do, I'll mark it as y. I'm marking it as y, and again keep moving right until I find a black symbol. Okay, so just keep moving right. When you are keep moving right, okay, so there is no need. So just let me say, now when you marked it y, now you are standing at here. So when you are at Q2, you are standing at here. You have marked it right. You have marked it a y, and you are standing till here. Now what you do at this state, now your pointer is standing here. Now you again move towards the left one. Okay, so when you are moving towards the left one, you will find the number of A's. Okay, so you have to keep moving till you find this X, and then move right, and then again write it, move it, change it to X. Okay, so now you are here. When there is a B, you made this Y, and you are standing here. So now what I'll do, I'll move left. Now I move left. Now I'll move left. In that I will find the number of A's. Okay, so I will find the number of A's. So what I'll do, do not do anything. So do not do, I will stop at here and then move right, and then write a X here. So I do nothing, and I keep moving left. Okay, so keep in mind, I just, it will be a little bit different that we have done, but it's very easy. So you will keep moving. If there is a in the path, you keep moving left until you find this X. Okay, so when you are finding this X, what you do, when you are finding this X, when you're finding this X, what you'll do, you do nothing, just remain this X as it is. You are not marking anything, but you will move one left. Okay, so now you are standing at this one. Okay, so now you are at Q node. Now again there is a, it will be marked as X, and you will move to right. Okay, so again there is a, it will be marked S, and it will be moved to right. Now you're saying it will keep moving until you find, until you reach a B. Okay, so in the, now if you're seeing here, there is another thing that you in the path you will also get a y here. Okay, so in the path you will also get a y. So I again have to include
Sir,
that. Yes, yes.
sir, in the step that you have done Q2 to Q0, sir,
Mm-hmm.
won't it be as a right shift?
When you are, yeah,
Yes.
sorry.
Yes.
Yeah, that will be a right shift. Okay, so I will again do this again. I will shift to right and mark it X. Yeah, absolutely. This will be a right shift. Okay, so that's a mistake of mine. Now, when you are here, now you are here again. You have marked it X and started moving towards the right of it. Now in this path, you will get a that is already defined, but you will also get a y here. Okay, so define this one as well. But you are, when you are occurring a y, don't do nothing. So it will be y as it is, and you keep moving towards the right. Okay, so that is important part. Most of the time we always forget about this one, that we also got a y in the v. Okay, so again in the first step I can also do that, but I just want to show you that how it actually works. Okay, so now there will be a y. You keep moving, you just don't do anything with the y and keep moving right. Okay, so now there will be a b here. Now there will be, you mark it as y. I mark it as y now, and I start moving towards the left of it. Okay, again now when you are moving left, now see, you are standing here and you are moving left. Okay, so when you are moving left, you will also get y in the path. Okay, so when you are getting y in the path, you don't do anything. So keep the y as it is, and you keep moving left. Okay, so that was also remaining in the previous one. So if you take one or two example, you will easily get it. Okay, so that is why this part is also included after. Okay, so that is why you will find this path in the second loop. Okay, so now you keep moving left. Now it is keep moving left, and in the path again, if you're seeing, what you will get, where are we exactly? I think we are here now. Exactly, we was here. Yes, we were here. There are, in the path there are y, and then there are b. We keep moving left till we got x. Okay, so now we are here. Okay, now till we got a x. Now we x, and then we got a x, and then just remain the x as it is and move to right. Okay, so that will be your now I think everything is complete. Now you will be standing at here. Now again I have to tell you about the final state also, so how to accept this particular thing also. So now you are again it's standing at here, you move, change it to the x here, so it will again move towards the right. Now see, now this is a loop, so it denotes that you will in the way you will get the number of y's. So it keep moving, so keep moving towards the left of it, and then there is a b here. Okay, so when there is a b, change it to y and keep moving left. Okay, so move it to left. Okay, so when you are moving left, there will be number of y's, there will be number of y's now, because they are, because you are standing at here, only there will be y's because all the a's are finished here. Now when you get a x, first x, okay, so when you get a first x, you just remain the x as it is and you move it to right. Okay, so you will stand at here from this q node. Okay, so now it means that your when you get a x and you remain the x as it is, first x remain the x as it is, and you move it to the right. So you are standing at here. Now all your a's and b's are open. Okay, so now how to accept this one? Now what you do, okay, so now you are at this state and your pointer is at here. So after x, when you immediately find a y, it means that all your marking is totally over. So now what you do at q naught state, you have to accept it also. Okay, so now you will stand, this is again just a courtesy that to move your pointer at the blank spot. I'm just moving it to the blank spot. Now when you find a y, you just keep moving it to y and you moving it to right. Okay, so just when you find here, just keep moving towards the right of it. Now I again have to write the loop for it, and there is a y, just remain the y as it is and keep moving right. Okay, so now when you reach here, the till for this particular state that you are q3, you will reach till here. Okay, so when the y's are over. Now what you'll do, you now can accept directly accept it. So you will, now you will get a blank, so remain the blank as it is, remain the blank as it is. So again remain the blank as it is, and you can move towards the left or towards the right, it depends upon you. Okay, so if you want to take your pointer here, you can take your pointer here. If you want to remain here, that depends on you, but because I have to again either do a left or right here, because I already know that after x, if I got a y, my all the inputs are directly equal. Okay, I'll again tell you about how it is equal. Here you can write left or right. So I again writing a left, so my pointer will end at here. So just it's a common courtesy that you end your pointer here, but if you want to end your pointer at the blank, that you can also do that. Okay, so now what you will be thinking, that how this particular machine is making sure that the number of a's are equal to the number of a's. Okay, so that will be more clear if I take an example where the number of a's are not equal to the number of b's. Okay, so now take this example as aa and then there is a bbb. Okay, so now you will see that in this particular input you will land at that transition which is not defined in this machine. Okay, so if you land at that transition which is not defined in this machine, you call that a dead configuration, and you can directly say that this particular thing is not accepted in the machine. Okay, so now to start with a, now what exactly is this saying? Move a right as x, right as x, and keep moving right. Okay, so keep moving right, there will be a there in between, there will be a, but just keep moving right, and then when you got a b, change it with the y and keep moving left. Okay, so I'm here and I'm start moving left here. So in the way I will get number of a's as well as a number of x. So I will get a number of a's, sorry, I will get a number of a's, and then when I got a x, I do not do nothing, I do not do anything, so just I stop here and I move it to the right. Okay, so this is a transition. When you got a x, you move it to the right, I move it to the right again. So then again there is a, you write that as x and you keep moving right. In the right you will get number of y's as well as you can also get number of a's. So in this particular case we only getting number only one y, So I'll keep moving right. So I will again stand at here, stop here, and again this particular transition is saying that change this b to y. Okay, so now I'm changing this b to y, and I'll move left. I'll move left. Okay, so I'm moving left and change. I'm standing here now. This q2 is saying you sorry. Okay, so when you change this to y, so the left is your this side. Okay, so when you change this to y, keep moving left. Okay, so when you move left, so just I write it, I got confused in left and right. Okay. Okay. So now when you write up y in place of b and you keep moving left, move one left, and then there is a loop. So in the place you will get number of y's here. Yeah, I got one y, and I'll keep moving. I'll keep moving left until you got a x. Okay, so I got a x here. I got a x here. Now I will move towards the right. So my pointer will be at here at q node. Now what is happening at q node? It is saying I do not got a here. I do not got a here because I am standing at b. So it is just saying that what you're saying y and y. So just keep moving right. Okay, so when I keep moving right, so first of all I will do this transition. I will move one right because I'm standing at here. I will move one right, and then there is a loop that when there is a y, just keep the y as it is and keep moving right. So I'll keep moving right, but I will only get here. Now it is saying that if there is a blank and then there is a blank, and then you can move it left or right and you can go to the final state. Okay, but here it will stuck at b. Okay, so this particular thing is not defined here, that what happens when there is a b here. Okay, so that means that that state is not defined when you got a b, when you got a b, and when you got a b, what to do here and which way to move. Okay, so this particular state is not defined at 3. You can say that this is your dead configuration, hence this particular string will not get accepted. Okay, so that is the beauty of this machine. Okay, so I hope you get this particular thing. If you have any doubt, you can ask me. We will do plenty of questions so to get how we do this machine. Okay, so now if you understand this one, I think you can easily draw a Turing machine for this particular question, that a raised to power and b raised to power and c raised to power. If you remember, we are not able to draw push down automata for this particular question. Okay, so in this particular question I will again write n raised to power greater than equal to 1 here. There is a no epsilon because Turing machine cannot accept epsilon. Okay, so now again the thing will be same here. You can take this example to draw this Turing machine. Okay, so you can take, there is a blank here, there is a blank here. So first you can say that it's a x, and then it's a y, and then it's a z. Okay, so again start move towards the left, x, y, and z, x, y, and z. Okay, so try to solve this one. I will tell you the solution in like 5 minutes. Okay, take your time. Okay, so if you draw it yourself, it will be very good. It will be very beneficial to you. Okay, try, take like 5 minutes. Okay, so again, follow the same procedure. There is nothing different here. So again, the in this particular question, I have taken two steps, but I will do this in only one step. Okay, so now what you'll see now, the starting state. You assume that your pointer is standing at here. So what you'll do, again, if particularly it is given to you that your pointer is here, so you can say that when there is a B, so remain the B as it is and keep moving left. Okay, so you can do this, but most of the time the pointer, it depends upon your choice, so there is nothing particularly, so you can take your pointer anywhere when you're starting this question. Okay, so I'm taking my pointer here. So first step, what I'll do, I will take a and then I remain the X as it is, mark the X in place of A, and I keep moving right. Okay, so I'll keep moving right, so I have to take a loop here. I keep moving right when there is a and there will be number of A's here. There will be number of A's. Don't worry about it. Keep moving right, and then uh, there will you get your first B. Okay, so you will get your first B. What you will do, you mark it as Y and keep moving your right. Okay, so now in this place, when you are keep moving right, and the second time you will also got a plenty of B's here. Okay, so when the second loop, in the second loop, you will find that when you keep moving right, in that place you will come from this one, so this will be a Y, this will be a Y. So in place of it, there will be number of A's as well as a Y. So I'm again defining here only that there can be also another Y's. So you can define it as Y, where keep the Y as it is and keep moving right. In the similar way, you keep moving right. Now we just keep moving right. In place of this, there will be a B, Y, and you are writing Y and keep moving right. You will find your first C. Also just write there in between, in the path you will also get plenty of Y's, plenty of B's. So remain the B as it is and keep moving right. Okay, another one can be that in place, you can also, okay, so I don't want to confuse you. So now you will get your first C, mark that C as Z and keep moving. Now you have to move left. Okay, so when you got a first C, you will here and mark it and keep moving left. Okay, so in this particular place, when you are moving from this one, from B, what exactly is there, that you will mark this B and keep moving right. In this place you will also get a number of Z's in this place. Okay, so I'm again defining. Okay, so I'll define in the next part so you don't get confused there. Okay, so now in this particular place, now you will what you will do. Now in this particular place, there are many things occurring here. Okay, so now you have to reach it to the first X. You are here and you have to reach it to the first X. In this you will get plenty of B's, plenty of Y's, and you will get A's and X's. Okay, so just write like this. When you're getting from here, you will first get a B. Okay, so when there is a B, don't do anything, just keep moving left. After B, there will be a Y. So when there is a Y, don't do anything, keep moving left. After that, there will be, I think, A. Okay, so there is a A. When there is a A, don't do anything, keep moving left. Okay, so now you will get to a X. When there is a X, okay, so when there is a X, you don't do anything and you move one step towards the right. Okay, so I have moved one step towards the right. Now I'm standing here. Okay, so A. Now I got a I changed it to X. Now I change it to X. Now there will be in the path, there will be A. So there is a there is a Y also. So there is a Y also. So I included this one in the previous step. But if you want to do not avoid any confusion, you can run it for two steps. Okay, so in path you will also get a Y. So I taken that Y here, and then in path you will get a B. You will get a B here and you change it to Y and keep moving right. Okay, so there will be a B, and if you're seeing, there will be a Z also. Okay, so there will be a Z, so define this particular one. There will be a Z. Do not change anything, keep moving right. Okay, so that path was also missing. So again, you will think, so you, when you are doing this question, particular questions, you think like this one. Okay, so it will be very easy to you. You just take this particular thing. Okay, so this particular thing. Okay, so when you are here in the second, you can directly draw your path for the second loop. Now you will be clear that these are some hidden transitions that will be only visible then when you
Sir,
are doing the second loop. Yes, yes.
sir, in the Q3 state, when we'll be moving left from Z, won't we also encounter another Z?
Yes, yes, absolutely in Q3 state, but I will define it. So that is why I taken two loops. Okay. Okay, so just now,
Okay, sir.
okay, so now you are here. So this one is again defined. You keep moving right, and then you will reach a C, change it to Z, change it to Z, and you move left. Okay, so when you are moving left, you will again find another Z in the part. Okay, so that is why this path again has to be defined, that you got a Z, do not change the Z and remain as it is. Okay, so now for this particular Z is also defined. Now again, your all the things are fine. Now what will happen in the last one, that again it will be marked X and then Y and then Z. Okay, so your pointer will be here, here when you reach. Okay, so just let me see, your pointer will be at the X. Okay, so there when you reach again at the Q node, your pointer will be at X. Now what you'll do, when you got a X, you just, now all the markings are marked here. You can say that there you are moving towards the right. You are moving towards the right when you got a Y, because when there is a X, you do nothing, you move towards the right. When there is a X, you do nothing, you move towards the right. Now you are standing here at the Y. Now when there is a Y, do nothing, keep moving right again. Now there will be now two things here. There will be a Y as well as Z. Okay, so I want to go to the blank state. Okay, so now in this place there will be a Y, keep moving right, and then there will be a Z, just Z, keep moving right. Okay, so now when you got a blank symbol, just remain the blank as it is. Either you can move right or you can move left. There is nothing to it. Okay, so there is nothing, there is no problem. Either it can be right or left. We're just moving towards the final state. Okay, so that will be your Q4 and that will be your Q5. Okay, so it's very easy. If you see that it is it is very easy compared to push down automata. Okay, so if you're saying, you just have to take this is your transition diagram. If you want to define it with the transition symbols also, so the transition can be defined as in the automata also. So it can be written as that you are at Q node. Okay, so actually the transition, exactly what was the transition symbol, this was Q into X and then Q X left or right. Okay, so you are at Q node and then you got input of the tape symbol, and then what you'll do, you are at Q node, you stayed at Q node, and you place you write the symbol X and you move towards the right. Okay, so again that you can define, if you want to define in this notation, that is also possible. If you want to define the transition diagram, is a more efficient way, I think, to understand very clearly, because in many books you will find only these transition symbols here. Okay, so that kind of a notation will be given in many books. They will not, most of the books do not provide you a transition diagram. Okay, so without transition diagram, I don't think you can very intuitively understand that what exactly is going on. But if you draw a transition diagram, now it's very easy to write like this. Okay, so that is very easy part, but I always prefer that you draw a transition diagram for complete understanding. Okay, so now I think your time is over, but you try this question. So if you
Sir,
see the, yes, yes.
so can we also move the terminating condition to the left blank instead of using the right blank?
Yeah, yeah, that is fine. You can also
It will
use
just
left or right. There is no problem about it. Okay, because my main motive is that I have to reach a blank. When there is a blank reached, it means that all the x, y, and z is are over. So it means that the number of x's, y's, and z's are equal. So now this is just a formality that I have to move left or right. That depends upon the user, but just I wanted to make sure that I move to the final state. Okay. Or you're asking other thing.
No, sir, got it.
Okay, so for your homework, you can try. I will tell you about in the next class. So I will discuss more, two more questions about it, and three or four more questions will be discussed in the previous.
Baba nerede çarşafım? Gördüğüm bu paketler benim dermanım.
Okay. Okay. So now the next question, if you try it yourself, that is your ones complement. Okay, so that is very interesting question. So that also you can also see this thing that your Turing machine as a transducer. Okay, so that makes sure, because if you know what transducer is, the definition is when you can convert one form of input to another form. Now in this particular case, now input, now your input can, because it can read and write as well. Okay, so read and write as well. So you can take a 1 and change it to 0. So that is the beauty of this Turing machine. Okay, so try this question, or try one's complement. If you want a little bit complicated, you can try two's complement also. So I'll tell about the both. I will draw the Turing machine about the both of it in the next lecture, so you will get a better idea of how to draw a Turing machine. Okay, so now I think your lecture is over and time is finished. And if you have any doubt, you can again always ask me on the mail as well as here. And you